We've seen the parabolas, whether it's opens, oh, that was bad. Whether it opens downwards or maybe it opens upwards, whatever. But now it's going to go full circle on us like this. And it's not too bad. I mean, yeah, we got that form. Some of you guys look at that standard form for the equation of a circle. And you kind of see that it looks very similar to the Pythagorean theorem, which is good if you notice that. Not that everyone does. But if we took any point on the circle, it would just be considered x, y. It's very abstract. But then you can make kind of a right triangle with the center in that point. All right. And then once you find this distance here and then this distance, the two legs, you would find that both those lengths are x minus h horizontally, and then y minus k vertically. Again, that's assuming the center is hk. You don't have to fully understand that. It's just that's where it comes from. Okay. Right, because this would be one leg and we've squared it, and this is the other leg. We've added those two squared, and then we've got the hypotenuse, which is just the radius squared. For a circle, right, if you got the center of a circle, if we were to look at any point on the circle, on the outside of that circle, like this one, it's the same distance from the center to that point as any other point on that circle. So if I chose this point, it'd be the same distance right there. And just an easy way to describe that is the radius, all right? So we want the equation of the circle centered at 8, -1 with the radius of 5. This one's nice. I mean, all we're doing is just replacing h and k and then the radius. We'll evaluate the actual radius though. So, for example, the h and k values come from the center that they gave us. The h is the x value, right? So 8 right there. And then the k is the y value from the center. And that's -1, but if we put in there minus -1, it's going to make that +1. So that takes care of that part. Then we got the radius, which is 5. And we'll just do 5 squared right there, which is 25. That's it. All right, we need to find the center and the radius for this one. Not really the equation, but we're going to manipulate this thing so that it will give us the equation. And it looks pretty awful when we first look at this. We're not used to seeing x's and y's certainly squared like this on the same side of the equal sign. But we know from the form that we want them on the same side, right? So just that they're on the same side right now is okay. We just want to look first at like terms, okay? So we're going to start with the x's. So I've got that x squared, and I've got a -10x. And I'm going to move those closer together, right? We're using the commutative property of addition here. And then we can look at the y's. So I've got y squared and that positive 14y, and that's good. Now I don't really want just constants like that, +10. I want that on the other side to be part of the radius, right? And that should work out all in the end. If this looks pretty in the end anyways. So I am going to subtract 10 from both sides of the original equation, which would have given us equals -10 right there. Now this sets out pretty well for us. We should have an idea of what we want to do at this point in order to make it in that standard form of the circle, which is at the top right there. And to do that, what we will be doing is completing the square for the x's and the y's. Just remember, if we add something, which is what we'll always do, to one side, we're going to have to add it to the other side as well. So, for example, the x's, we're just focusing on the x's right now. So I'm really ignoring the y's right now, okay? I want to complete the square right there so that we have a perfect square binomial. So I'm going to take that -10, which is our b value, and we're going to make it negative 10 right there. We're going to divide it by 2, but we got to square that. And that will allow us to complete the square, right? So what does this do? It gives us x squared minus 10x plus, we'll work inside the parentheses there. Negative 10 divided by 2 is negative 5. And we're going to square that. And we can see from that negative 5 squared that that's going to end up being 25. Okay? So this is going to drop and become 25. 25. So what I ended up doing really is just adding 25 to the left side of the equation. So that negative 10, I'm also going to add 25 to it as well. Well, that was completing the square, so it should give us a perfect square. So I should have x minus whatever we took the square of, and that was negative 5 here. So it's minus negative 5, and then we can square that. Of course, minus negative, we're going to make that plus right there. And we're done with the x portion of the equation. Now, it didn't really ask us to find the equation from the beginning, right? But if we have the equation, then we should be able to figure out what the center and the radius is from there. So let's move on to the y values. Right, let's look at that x squared minus 10x plus 25. All right, now this is perfect square trinomial, right? What this is going to do is allow us to split this 25 up. Right, because I'm looking for two factors of 25 that add up to negative 10. And specifically, we're looking at negative 5 and negative 5. So what does that do? It gives us, yeah, we got the x values. Now these ones, the x squared and the y squared have coefficients, which we don't really like that very much. And that's okay. Let's go ahead and start moving the like terms closer to each other, just like we did on that last one. And once again, I'm going to subtract 57 from both sides, just to get the constant on the other side of the equation. Before we move on, we don't really want those coefficients of the squares, x squared and y squared, to be anything but 1. So I want to get rid of those 3's really bad. I don't like those 3's being there. So what I'm going to do is I'm going to look at this 3x squared minus 24, and I'm going to factor out a 3, because 24 goes into 3 pretty evenly right there. So I end up with 3, and I got x squared minus 8x now, and that looks a lot better. But not only out of that one, but also the y's. I can also factor out a 3 from there as well. So I've got y squared minus 4y. That's going to be a lot easier to find the to complete the square on those. But in addition to those that we factored those 3's out, we don't really want them there either. So some of you notice that 57 is divisible by 3, right? 5 plus 7 is 12, which is divisible by 3. So as it turns out, we can divide all the terms by 3, which gets rid of that 3, which we could distribute it back in, right, and get what we had from the beginning. Now that may be a little confusing just because of the steps that we took. However, if we were to look back and look at the original equation right here, you could have factored out a 3 right there and then divided both sides by 3, and you would have had this simplified expression from the beginning. So it doesn't matter where you do it, just as long as you do it. So we don't want a coefficient of x squared or y squared right there. So what does that give us? Negative 19, negative 57 divided by 3. Mm-hmm. And we see now a new equation which, well, it looks a lot easier. Looks like it's going to be a lot easier to deal with than the originals. So what are we going to do right here? We got negative 8 right there. So we're going to add negative 8. We're going to divide it by 2 and then square that so that we can complete the square on this one. So that's x squared minus 8x plus that'd be negative 4 squared. So then it's x squared minus 8x plus 16. So from the negative 19, we're going to have to add 16 as well, right? Splitting the two sides up. And if we were to factor that out, then we got this perfect square binomial x minus 4 squared. All right, let's do the y's now. So the y's, y squared minus 4y. And we're going to take that b value of negative 4. We'll divide it by 2 and square that. So now we got y squared minus 4y plus negative 2 squared, which is y squared minus 4y plus 4. So I added 4 to the y, so I'm going to have to add 4 also to the right side of the equation as well. And now we can factor that. So we got y, and then what was inside the parentheses was that negative 2, so y minus 2 squared. And of course we'll add those two together. And this equals negative 19 plus 16 plus 4 is 1. Alright, so we have this in standard form for the circle, which is what we wanted, so that we can figure out what the center is. And right, if we were to compare this to the standard form, well, I can see the h value is just directly this 4 right here. And then the k again is very direct, it's just that 2 stuff. If it was addition, right, like y plus 2, then we'd have to look at that as minus negative 2, which would change the value of, or the sign in the k there. But for now, this is our center. All right, what about the radius? The radius squared is 1. So we'll just square root both sides there. And the radius, well, it's still 1. 1 unit, again, I didn't really tell us what any of the units were, so we'll just say the radius is 1 with the center at 4, 2. Find the standard form for the equation of a circle, right? That's the equation that we want, with a diameter that has these endpoints. So what we're going to want to do on this one is, well, we can find the distance between these two, right, using the distance formula. What that will do is the distance in this case is the diameter, and the radius is just half of the diameter. So once we find out whatever that distance is, we'll just cut that in half, which gives us the radius. Yeah, it doesn't matter if you put the 1s and 2s and alternate those. We'll say that this is x1 and y1 just because it came first, right? So let's go ahead and replace those values. And then we'll say this is x2 and y2. So we'll replace those in there. All right, let's go ahead and evaluate this thing. And that distance then would be 13 units. Now that's the distance between those 2 points, which means it's also the diameter, which is important for us. So if we want the radius, we'll just cut this thing in half. I don't know, you could use the decimal if you wanted to. What the heck, 6.5. If you want to use the fraction, that's fine. Either way is okay with me. Alright, all we need to do is to figure out the middle of those 2 points, which is the center. So the midpoint formula, right? And we already got these labeled, so I'm going to replace the values in there right now. So let's go ahead and evaluate these. Negative 3 plus 2 is negative 1 over 2. We can just leave that as a fraction if we want. And then negative 5 plus 7 is 2 over 2, which is 1. So negative 1/2, 1. The midpoint also gave us the center. All right, there's, we'll circle those. There's our 2 answers, the radius and then the center. Yeah, now let's put this in the standard form for the equation. So let's go ahead and fill those in then. And yeah, we got that minus negative stuff in the parentheses there. We'll make that plus. And then 6.5 squared, 42.25. And it looks like that's going to be our actual final answer right there. All right, that was pretty formal, a formal way to find the equation. Let's look at a maybe different way that some of you may find pretty useful on this. All right, so just like we did with slope, right here, and I am going to find the distance between these two first. Is we got 0, 3, and -9, -6, right? So from 0 to -9, that means you would have to go to the left 9. I guess I should have connected those beneath, right? And then from 3 to -6, you would also have went down 9 as well. Now, if we were figuring out slope, we'd do -9 over -9, which is great. However, right now we want distance. What this means, and what we've just done really is, if we would look at the graph, right, 0, 3 is somewhere in this area, and then -9, -6, I don't know, somewhere down here, right? The -9 and the -9, the purple and the red ones that we just found, are really the distance, or the lengths of the legs, right there. So this one we could say is -9, and this one is -9, which also gives us a positive slope between those two. Now, you know, we'll end up drawing a circle eventually. But this is diameter stuff, right? So those are the lengths of the two legs. Now, if you went the other way, you'd have positive values. You're going to get the same thing because we're going to square these, right? Which means if I wanted to find the hypotenuse, I would just take this, well, I guess we don't even have to square root it. We got the -9, and we're going to square that, and then we'll add it to the other -9. I should have put those in parentheses. -9, and we're going to square that as well. Right now, that would give us the length of that hypotenuse. So this is the square root of 81 plus 81, which is the square root of 162. Now that is the diameter, right, between the two points that they gave us. But what we really want is the radius on this thing. So we're going to have to divide that by 2. And we have the radius. All right, the other thing is we need the center of this. And we already, like we look at the picture, right? We see the horizontal and vertical change. So I'm just going to go halfway for both. Which means if I were to start at this point, that's the -9, -6. I'm going to go halfway to the right from -9, which would mean I'm going to go to the right 4.5. Well, where does that put us at? Well, that would be -9, and we went to the right 4.5, which puts us at -4.5. And then upwards as well, would have to go up 4.5 from there as well to get halfway of that -9. So I got that -6. We're going to go halfway up the 9. So we're going to go up 4.5, which would give us -1.5. And that would give us the center, you know, somewhere in this area. Which, well, that should kind of make sense right there. So that's the center. -4.5, -1.5. And hopefully we can see, I mean, if we were to draw this really nice, it'd look something like this with the circle. But again, they didn't want the center or the radius, they just want the equation for this thing. So let's go and write that in. And we got the h value at -4.5, so that would be plus 4.5 right there. And the k value at -1.5, so we'll make that plus 1.5 as well. The radius, which we're going to square, was some kind of fraction stuff, right? Square root of 162 over 2. Let's go ahead and evaluate that thing. So we'll square both of these. I got 162 over 4. Now it doesn't go into it evenly, but we can simplify this thing. We'll just divide both of them by 2. So that gives me 81 halves. So our final answer . Draw a circle with the center at 2, -2, and a radius of 1. All we need to do is graph the center, and then we'll find other points. We'll find points that are 1 unit away from that point, which would give us the actual points on the circle. Okay, so let's identify where 2, -2 is, right there. But not only that, let's go ahead and identify points that are 1 unit, where we know they're exactly 1 unit away from 2, -2. All right, so I'm going to go 1 unit to the left, which gives me this point. I can go 1 unit up, which is that point. 1 unit to the right, which is this one, and then 1 unit down. It's a very small circle, but you know, that's the circle right there. Let's go ahead and bam. I colored it in just because that's what the program did, but you don't have to. All right, we're really just kind of focusing on the outside of that thing. So you know, something like this. I know on the test I'm not looking for anything perfect, so I mean if you want to bring your compass, it's kind of nerdy, but it's acceptable. Alright, so it wants us to graph this, and yeah, it's in 7.9, so we should assume that it's going to be a circle. So I mean, no, you know, try not to freak out about it. What we'll want to do here is complete the squares. Well, the square for x squared plus 4x. Because y squared, if we wanted to write this in the standard form for the equation of a circle, we could just make it y, well, minus 0 squared. And that's pretty nice. All right? But we got to do the x squared plus 4x. So if I were to complete the square, I would take the b value 4 divided by 2 and square that. So x squared plus 4x plus 2 squared. So x squared plus 4x plus 4. So I'm going to have to add that 4 to the 5 as well. And some of you notice 4 plus 5, or 5 plus 4, is going to give us 9, which is a perfect square for the radius, which is kind of what we should expect. Completing that square, right, gives us the binomial x, and that was a positive 2, so x plus 2 squared. Which we'll put into that part of the equation then. Well, from this we should be able to identify the center, and yeah, we could make that x minus -2 squared. So we see the h value is at -2, and the k value was already given to us at 0. So I got -2, 0. At this point, that's our center. But what about the radius? The radius right now is 9. But that's the radius squared though, right? So we're going to have to square root both of these, which gives us a true radius of 3. So from that green point on there, I'm going to go 3 units up, which would put us at this point. 3 units to the right, 1, 2, 3, this point. 3 units down at this point, and 3 units to the left at this point. And yeah, we can, you know, that's acceptable. I mean, here's what I don't want to see, right, is, I mean, you got your points over here, and it's just like, oh, there we go. Good, right? Well, no, I mean, try to make it close. I mean, mine's not perfect, but I'm somewhere in the range right there. I mean, even if you're just, oh, that one turned out pretty good. You know, I mean, something like this, it's kind of sloppy, but at least it looked like you tried to hit the points. Right, the one on the outside is no good. So this is what it wants us to graph. So again, let's look at the standard form for a circle. So the nice thing is they gave this one to us. No need for completing the square at all. They gave us the center. At the h value was given to us directly at 3. That's y plus 2, so we're just going to make that y minus -2 right there. So the k value is -2. So let's go ahead and graph that point, 3, -2, right here. And then we also see from here, right, the radius squared is 4. So we'll just square root both of these to get the radius of 2. So again, from that center, the red point, I'm going to go 2 in each direction. I can go 2 up, 2 to the right, 2 down, and 2 left. So that just give me, again, it's just giving me some points to aim for. I think on the homework, you guys just choose the center and then I think another point on the graph. Maybe you tell it what the radius is. I forget. But in any case, we can start graphing this thing. Again, it's not perfect, but that'll do. Find the equation of the circle. I mean, if we think about it, right, the equation that we want should be in standard form. Well, this one actually gives this to us pretty directly. The center of the circle, right, if I were to look at two opposite points, these two, could you use these two? Sure you could. I would be cautious of using any others, but these ones are on X and Y value lines right there, okay? So, right, if we looked at the purple, this is 6 across, so I would just find halfway between that, and that would give me the center. It works the same way for the red line. That's also 6 units, and then halfway of that is just 3 units up or down, depending on which point you're using, right? So that does give us the center right here at -1, 1. Well, that allows me to go into the equation right away and fill those out. So that's -1, 1. And we'll change that in the next step. Well, by doing this, we kind of figured out the radius, right? The distance between these 2 points is 3. So the radius, we know, is 3. And we can do 3 squared, which is 9. And then this portion right here, we'll just make that a +1 right there. And this right here would be our final equation for the circle that was given to us.